Good morning. I welcome you all to the mathematics class. Um, we remember we are presently dealing with the basic algebraic identities. And these algebraic identities, in its basic form, comprises of what is known as square identities and the cubic identities. So by the square identities, we mean those form of identities that has to do with power of 2. For instance, if I have this expression P plus Q raised to power 2, right? So this one is something similar to what is an example of what we mean by square identity. And possibly, I also can have P minus Q raised to power 3. So once it is dealing with power of 3, to term or refer to it as cubic identity. But for the time being, we are presently dealing with the square identity. We want to complete the square identity, then move over to our cubic identities. Because we still have other identities higher than these two that we have here. But what we simply do is application of this square and cubic identities is what we also use in tackling any other form of what of identity. For instance, I may be asked to find P minus Q raised to power 5, right? What I will simply do is to say that anything raised to power 5 here means P minus Q raised to power 2 multiplied by P minus Q raised to power 3. So, meaning that we need the thorough understanding of square identity as well as cubic identity in order to be able to excel in identity. And also try and remember some of the objective or some of the advantage of these identities that it makes our calculation to be faster. Not only that, it also helps us not to do what to learn too many topics before we can be able to do what before we can be able to address some questions, because there are some questions as you are moving from normal equation, you move to change your subject or formula, from change your subject or formula to applying simultaneous equation, quadratic equation, and so on. But with this help of identities, we need not to know all those so many topics like that before we can be able to solve a very complex question. So let me say that is one of the benefits or advantage of these identities. And we also remember that the exam which we are dealing with, right, do not specifically contain identity, but identity is always tested. So since identity is always tested, it is important we understand and know these identities very well. So presently we are still dealing with the square identity. So we are going to continue with it today. But before we continue, so out of the two assignments I gave out the other time, I quickly want to solve one out of the two and I will leave the other. So the reason why I'm leaving the other is one of those assignments, especially that number 2, the second assignment, right? We at the end of the day lead to factorization, right? So since it will lead to factorization, the factorization is beyond all those normal quadratic factorization that we know. There are many other tricks of factorization, right? One of those tricks is the one known as SFFT. Then another one is Sophie-Germain identity or Sophie-Germain factorization, right? So since all of these things is still needed, so all of this we are going to learn them under the factorization. So any identity that will lead to factorization for now in this class, we are going to drop it, right? So we will not attempt it. So as a result, so I'm not doing the correction to the second assignment, but rather only the first assignment. And we can see this one is very easy. So when we observe this one, you can see it is illustrating identity that talks about what? The difference of two squares. So since it is difference of two squares, so solving this thing simply means everything we have here becomes, so I should concentrate on either of the two brackets and pick those values I have there. So the value I have in this one is square root of 2. The second value I have there is 3y. And all I want to happen is minus must exist between them and I must square this and this. All right, so and if these things are squared, the result this gives is 2. minus 9y squared. So solution to this question simply means 2 minus what? 2 minus y squared. That's how that is done. So but for today's class, let's begin with questions. So we have couples of questions to also talk or discuss today. So number one now, find the value of x minus y when x plus y is equal to 9 and xy is equal to 14. So that's the first assignment. That's the first example we are going to be talking about today. All right, now remember, I'm not bombarding us with too much, the application of too much identity now. So all the identities we want to be using, for even throughout this week, is still going to be based on the square identity. And once it is square identity, right, so we should be able to record those ones easily. Now, back to the question which we are solving. We should always go to the requirement of the question first. Because in the process of solving the requirement of the question, right, so that requirement we also need application of the given. So once it needs the application of the given, then we can now revisit the given in the question which we are solving, right? And at times, this given too, right, may need some few manipulations in order to be able to do or to apply it. So it is advisable we always go to the requirement of the question. So what is the requirement of the question? The requirement means I should find x minus y. How can I find x minus y? So remember, it is identity we are dealing with. Now, what identity do you know of that is of this form x minus y? Do we have such an identity? So we can see when we look at the list of the identities which I gave to us so far. Under the square identity, we don't have any identity. Under the square identity rather, we don't have any identity of this form. Let me quickly do the short recap of this identity. One states that x minus y squared is x squared plus y squared minus 2xy. Another one states that x squared minus y squared is x minus y, then x plus y. Another one states that x plus y all squared is x squared plus y squared plus 2xy. And remember, I want to apply identity in dealing with this thing, right? So if I'm to use identity, this is what I'm asked to find. So which identity do you think will be used in getting this? Now check, these are the list of the identities which we have been given so far. So one of these three has to be used in finding this thing. So do we have any identities, right, that look exactly the way this thing is? So when we check it from here down to here, so we think there is no such identity. So once we don't have it, it's not that that identity is not there, it is here, but it is not there directly. So once we cannot trace it directly, so unlike the question we solved the other time, that assignment I did, so know that one can be traced to the question can be traced to this list directly. That was why solving that one is what doesn't take us anything. Doesn't take much time at all. But like this very one which we want to solve, so we need this x minus y, and we have it specifically defined from this, and this. So we can see it is not given directly. So once it is not given directly, we are going to derive it, right? So we are going to derive it. Now let's check this, and this. Then I also want to tell us one thing, right? That thing I want to tell you is the one that has to do with difference of 2 squared should not be used except if we have situation of x minus y and x plus y. Therefore, that one will not be useful here, because you may think that that one will be useful in doing this thing. So that one will not be useful at all. That one should be used in situation whereby we will have something, that thing will already form the difference of 2 square. So we don't have situation. This very question which we are solving is not in any way related to difference of 2 square. So difference of 2 square will not be used here at all. So it is either we use this or we use this. Now, which of these two identity now contain s minus y? Right? We can see partially we have s minus y here. But what I have here actually is not just s minus y, right? But this one will be used in deriving this thing. So we now go into this. Remember, the only way we can use this one to obtain s minus y is if it is possible for me to remove this power here. I can now say that what? I've gotten my x minus y. So that is how we derive the x minus y which we are given there. So in that case, I will say that x minus y squared, right? It is equivalent to x squared plus y squared minus 2xy, right? So let's continue solving. So we say x minus y squared here becomes, now, do we know the value of x squared? Or do we know the value of x? When we know the value of x, we simply can take its square. Do we also know the value of y? Or is it given? So once the value of x or value of y is not given, so it shows we also have to go and provide this one minus. So remember here I have 2 times xy is already given as 14. So exactly what happened here should have happened here, right? We can see this xy is given. So it was so easy to just say minus 2xy becomes minus 2 times 14. But can I do the same for this? And I did mean it is possible for me to determine x squared and y squared now. So I will just say the difference between this and this, right? So the square root will just give rise to the x minus y, which I'm asked to find, and we'll have what? Just finish what we're asked to do. But it is not like that. So we can see we don't have the value of x squared plus y squared. Now, what else can we now do to get x squared plus y squared? So in order to do that, we now need to go back to the requirement, to the given in this question, right? So remember, when given this, we are asked to find this. And when you look at what we have done so far, we've not used every given we have in this question. So it's only one of the two we have used, right? Therefore, we need this one as well. So this one is what will enable me to get or to determine this. And once I'm able to determine this, so I will just subtract this from this. I will find the square root, and I'll be left with x minus y, which is the requirement of this question. So to doing that, right, to using this now, I've not used this, though I've used this, I've not used this. How do you think I can talk about this? Then the next thing I also can do is, let's think of an identity, right, that is of this form. Do we have identity that is of s plus y? So these are the list of our identities which we have covered so far. We don't have s plus y defined specifically. Since we don't have s plus y defined specifically, right, let's pick something similar. So something similar to it is this, right? From this, we can now define or derive our x plus y. Remember I told you the other time that don't make mistake of referring to this s plus y here, right? This one is using on one condition. And on what condition? When the given already forms the difference of 2 square situation. So once we don't have that, don't ever think of using this one, right? So it is this one we are going to use. So since we want to work the given in order to be able to complete this solution, I simply can do that one here by saying that what x plus y squared, right? Okay, by saying x plus y squared, right? By saying x plus y squared, because I need this x plus y here. Now, what is the equivalence of x plus y squared? It is written here. That means x squared plus y squared plus 2xy. So remember, the reason why I have to consult this thing is because I need x squared plus y squared, right? And it's only this one that can enable me to get the x plus y squared. So remember in the given, x plus y is given to be 9. Here I can say 9 squared. is equal to x squared plus y squared plus 2 times 14. Here I can say that 81 is equal to x squared plus y squared plus 28. And I can say 81 minus 28 is equal to x squared plus y squared. I think that with 53 is equal to x squared plus y squared. So remember, we were stopped with this solution all because we don't know this. We don't know this. So that was the reason why we have to consult what we have here, right? This one now enabled me to define x squared plus y squared as what? As 53. So we can see in the position of x squared plus y squared now, I will substitute it with what? The 53. So I can now say that x minus y squared. So back to my solution is equal to, remember x squared plus y squared was gotten here to be what? To be 53. So I can here say 53 minus, what is 2 times 14? That is 28 minus 28, right? So here I can say that x minus y squared is, what is 53 minus 28? That will give 25, right? We have 25 there. So to get in x minus y here, I can take the square root of both sides. Therefore, x minus y here becomes square root of 25. So x minus y is equal to 5. And that's the requirement of the question. That's the simple requirement of the question. So the key issue in this thing, in solving this question, is we should be able to what? To be as fast as possible in order to think of what identity is related to what we are looking for, or what identity is in relationship with the given in the question. So with following all these processes, we are able to determine our x minus y to having the value of what? 5. Therefore, this is the complete solution to question 1. So the ball will be rubbed shortly so that we can move over to the next question. All right, number 2 here. Given that x plus 1 over x is equal to 3, find the value of x squared plus 1 over x squared. So this is our next question. So remember, like I told you the other time, when we are asked to solve any question, and remember it is identity we are applying in solving these questions, let's first of all go to the requirement of the question. What exactly are we asked to find? So we can see we are asked to find this. So let that serve as the first thing we are going to do. Should be the first step of our solution. So let me say my solution now. So I'm looking for x squared plus 1 over x squared. So this is what I'm asked to find. This is what I'm looking for. So I will continue thinking of this thing. I will continue manipulating this thing. So in the process of manipulating this thing, so there is no way I will now need these requirements. So this given I have is not just given. So they know that in the process of manipulating this thing, I will have no choice other than to do what? To come and visit this given. So when it is time for me to use the given, then I will apply it. But for the time being, this is what I'm asked to do. So with this thing I'm asked to do, what meaning does it read? What can we picture from it? So remember, it's identity we are dealing with. So it is identity we want to use. So out of the list of the 3 identities which we are using so far, now, which of those 3 identities does this thing resemble? So I will restate it. Remember, those identities are p squared plus q, p plus q squared, right? P plus q squared like this means p squared plus q squared plus 2pq, and p minus q squared means p squared plus q squared minus 2pq, and p squared minus q squared is what? P minus q against what? P plus q. So we know these are the three identities we are applying, right? Remember, the identity is much more than this, but for proper understanding of what we are doing, we are still concentrating on square identities. So since it's a square identity we are dealing with, so which of these identities does this thing resemble? So let's say the one it resembles. And note, remember that I said the one that has to do with difference of two square should never be think of, except if we have a situation whereby something plus something against something minus something, just like we exercised it in the previous class. So remember, when we have such situation, we never thought of using this and we never thought of using this. So once question does not come in this pattern, that one must come in the full pattern. Once your question do not come in this pattern, don't ever think of using this. So it now means that dealing with this thing is either we use this first identity or we use the second identity, right? Now let's look at this. What does this thing resemble? So we know what this resemble is. Case of a squared. Okay, since I'm using pq, let me say it resembles the case of p squared plus q squared. Now, let's check these two identities I want to use. Do I have p squared plus q squared defined? Do I have p squared plus q squared? Right? So I can see that p squared plus q squared is not defined directly, but we can get it indirectly. How do I get p squared plus q squared? So what I need is p squared plus q squared. P squared plus q squared can be gotten from here. P squared plus q squared can as well be gotten from this place, right? But let's say normally we have p squared plus q squared. So to derive my p squared plus q squared, so let me say p squared, since it has addition, Abi, let's say it's what? It can be derived from p plus q raised to power 2. So it is this one that will generate this. Or we can say this is a factor of this thing, right? So therefore, what is p plus q squared? We know p plus q squared means p squared plus q squared plus 2pq. And since what we are interested in is p squared plus q squared, what do we do in that case? We can make p plus q squared the subject of the formula here, whereby I can say p plus q squared minus 2pq is equal to p squared plus q squared. P squared plus what? Plus q squared. So I said this thing given to me, right? So since it is not given directly, right, we are going to derive it. Or what we were saying is this requirement of the question follows this pattern, right? But because this pattern is not defined directly, so we've defined it in this way. Meaning that what I'm looking for, I will now substitute it now. So the first thing is from this now. I have p squared here. So it means I'm looking for s squared plus 1 over s squared, meaning that it will be equal to x plus 1 over x, everything squared, minus 2 multiplied by p is x, this first item, x, while q is 1 over x multiplied by 1 over x. All right, so I can progress by saying s squared plus 1 over s squared is equal to, so from this okay, let me say this will cancel this, right? I'm now left with x plus 1 over x squared minus 2. Right? So from this junction now, what do? I have no choice now other than to refer to the given. And you can see we've not even thought of what? Of the given in this question. So the given will be useful now, right? Now we have x plus 1 over x, and the meaning of this given is that anywhere you see this relationship, go and call it 3. And we have x plus 1 over x, it automatically become what? Become 3. So it means x plus 1 over x here means 3 raised to power 2 minus 2. And we can say that gives 3 times 3 here is 9 minus 2. which has the value of what? 7. So given that this, find the value of x squared plus 1 over x squared. So x squared plus 1 over x squared is equal to what? Is equal to 7. Now, the next number. Find the value of 7.98 times 7. Okay, let me move it here. Find the value of 7.98 multiplied by 7.98 minus 2.02 multiplied by 2.02 over 5.96. So that's the question. So now let's think of it. Now, we are using identity, so we are not even asked to use, because this thing can be solved using logarithm, it can be solved using our calculator directly, but we don't want to use calculator directly. Suppose it is theory question we are solving and we are given this thing, and it is identity we are asked to use. How do we do this? So to doing it is, let's think, first of all, we think about the question. What does this thing resemble? Or what is this thing saying? So I simply can say this thing means 7.98 squared. Look at it, 7.98 and 7.98 the same thing as 7.98 squared. Then followed by minus 2.02 squared. And everything is over what? 5.96. Right? And you can see this is squared, difference. Minus is placed in between them, meaning difference of 2 squared. So to doing this now, we need to think of the identities about what? About difference of 2 squared. So that means using that identity, I'm going to say 7.98 minus 2.02 minus 2.02 against 7.98 minus 2.02. Everything over 5 point what? Over 5.96. We only need to calculate that area so as to be able to determine the result. All right. Okay, one should be minus, while the other should be plus. So here, let me say 7.98 minus 2.02. This gives 5.96 times, and here 7.98 plus 2.02. This one is 10 over 5. I think this thing should be 59.6. Let me recheck that question. All right. Now, this one is 59.6, not 5.96. 59.6. 59.6. 59.6. Okay, 59.6. So now when this is multiplied, we have 59.6 over 59.6. So this cancel this, and the answer is 1. Assalamu alaikum. Yes. Yes.